So we want to prove now, we want to intersection is 2, 3. So you have a line x minus y plus 1, and that's equal to 0. And you have another line x plus y minus 5, that's equal to 0. If you're to add these two equations, let's just add them. If we add these two equations, we're going to get x plus x is 2x, y plus minus y cancel, 1 plus minus 5 is minus 4, is equal to 0. And so 2x minus 4 is 0. And so 2x is equal to 4. And so x must equal to, x must equal to. Since x is equal to 2, we can resubstitute in a point up here. All right, so 2 minus y plus 1 is 0, and so y must be 3. Y has to be 3. All right, and so hence the center is 2, 3. Hence, the center is 2, 3. So that gives us the center of the circle. Hence, the center is 2, 3. Now that we get the center of the circle, we're looking pretty good. All right, we're looking pretty good now that the center of the circle is 2, 3. So that represents part A. All right, center of the circle is 2, 3. Now it says A and B are ends of the diameter. So anytime they're talking about diameters and endpoints, I just have to draw a circle. It just gives me a clear idea of what's going on. All right, so I'm just drawing this circle here. And it just really helps me when I do that. And I know the center of the circle is 2, 3. I know the center of the circle is 2, 3. I know that the line, you have the line y is equal to x plus 1. If I bring this over, I have the line y equal x plus 1. So that's a line like this, y equal x plus 1. So this represents L1. That's L1. Then the line L2 would be, bring over this, it would be 5 minus x. 5 minus x is a line coming from down here. This would be the line L2. I'm just sketching it. It makes me see what they're talking about. And they said that A and B are endpoints of L1. So looking at L1, A and B are endpoints. So you have A and B. And they tell us that given that the coordinates of A is 1, 2. So A has coordinates 1, 2. And the diameter bisects each other, determine the coordinates of B. Now that's so easy, like this is B. Like to get from here to here, remember the distance from here to here, let me put it like this. The distance from here to here is the same as the distance from here to here. All right, so the distance from A to the center is the same as the distance from C to D. So there's two ways you can do it. You could use the length of a line formula and say that the distance AC is equal to the distance CB. All right, so given that the two distances are equal, then that implies that B is going to be equal to the coordinates 3, 4. You might say, how do I know that right away? Look at it. You're going up by 1 for the x. You continue by 1. From here to here is 1. So increase in x by 1. So you go from 1 to 2 to 3. That's from A to the center to B. That's for the x coordinate. For the y coordinate, the distance is going to be the same. And so it's going to go from 2 to 3 to 4. That's the easy way to do it. All right, so B is a 0.34. Nice. Next now it says a point P moves in the xy plane such that its distance from C is 2, 3. Such that its distance from the center is 2, 3. And it says determine the locus of P. So it tells us that the distance from the center of the circle, so the distance from the center of the circle is root 2. So if the distance from the center of the circle is root 2, this is what you have. All right. I want to put a better sketch right here. Let me not use a circle yet. Let's say this is the center. This is C. C is the point 2, 3. And they're telling us that P is the point where P could be anywhere, P could be here, but all they're telling us is that P is the point such that the distance from the center to P is root 2. So they're telling us that this distance is root 2. So if this distance is root 2, P could be anywhere. As long as the distance is root 2, we could get one circle going around it. But as long as the distance from, as long as, let's say P is here, as long as the distance is root 2, we're good. And so this forms an equation of a circle. And so the locus of P, the locus is going to be given by x minus 2 all square, because it forms a circle, so it's x minus 2 all square plus y minus 3 all square. And that's equal to r squared, which is the length of the radius, which is 2. That's the answer. Nice and easy. So this was a very easy coordinate geometry question. Everything about it was easy. Everything. Nice and easy. So now let's look at the next part of it now. The next part should be parametric and vectors. So let's see. They tell us that the parametric equation is given by x is equal to